This lesson is over multiple representations through algebra representation. So we're using graphs, tables, and equations. We're talking about independent, dependent, making predictions. We're using everything we learned and putting it together. So this is a graph. This is a graph about bicycle travels. I keep some symbols here. So this should say hours, and this should say distance travel. So let's look at this. So in here, 1 hour of traveling is 15 miles traveled. 3 hours on a bicycle is 45 miles traveled. 5 hour is 75 miles traveled. 6 hour is 90 miles traveled. But what is the relationship between the hours and the distance traveled? Is it additive or multiplicative? I can see we're multiplying by 15. So we're multiplying the number of hours by 15. And that will give you the distance traveled, or y equals 15x. So to find the distance traveled, you have to multiply 15 by the number of hours, y equals. So even though this is not on here, dry mix, the distance traveled is dependent on how many hours. So if you manipulate the number of hours, the distance travel will respond to it. So dependent is distance travel, independent is number of hours. So each situation below gives two values of a proportional relationship. Insert on the table on a graph and an equation, and write as a summary to make a prediction. Owen was 3 years old when his sister Greta was born. So Owen is 3 years old when Greta was born. So when Greta is 1, Owen must be 4. When Greta is 2, Owen must be 5. When Greta is 3, Owen must be 6. When Greta is 4, Owen must be 7. When Greta is 5, Owen must be 8. What is the dependent and independent variable? So the dependent is Owen's age. Owen's age depends on what Greta's age is. She must be the independent. The dependent must be Owen's age, and the independent must be Greta's age. Write an equation using the relationship of Greta's age to this. So what is the relationship from Greta's age to Owen's age? See this, we are adding 3. So x plus 3, y equal x plus 3. If you know Owen's age, find Owen's age, you have to add 3 to Greta's age. Y equal x plus 3. Let's graph this now. So go pick a label. Let's see. Greta's age is the x-axis. Greta's Owen. If Greta is 0, her brother is 3. When Greta is 1, her brother is 4. When Greta is 2, he is 5. When she is 3, he is 6. When she is 4, he is 7. When she is 5, 8. We're adding 3 to her age. If Greta is 66, that means Owen must be 79. We're adding 3 to her age. Let's look at a different situation. So we just did an additive relationship. On average, it takes 4 minutes to complete each math problem. If you have 0 problems, 0 minutes. If you have 1 problem, it will take 4 minutes. If you have 2 problems, it will take you 8 minutes. If you have 3 problems, it will take you 12 minutes. If you have 4 problems, it will take you 16 minutes. If you have 5 problems, it will take you on average about 4 minutes each problem, 20 minutes. So which one is the dependent, the independent variable? Well, in science class, again, you learn it as by mix. The dependent response. The minute depends on how many problems you have. So what is the dependent? The dependent is the minutes. The independent, the number of problems. Really, this should be number of problems. Write an equation using a relationship of minutes to problems. So we are multiplying by 4, multiplying by 4. So multiplying by 4, y equal 4x. So y equal 4x. That's the point of minutes. You have to figure out how many problems there are. 4 minutes per problem. Let's graph this. This is the problems, number of problems. This is the minutes. If you have 0 problem, 0 minutes. 1 problem takes 4 minutes. 2 problems will take 8 minutes. 3 problems will take 12. So it must be multiplicative. So if it took you 60 minutes to complete the math problem, how many problems do you complete? So 1 minute, 4 minutes for 1 problem, 60 minutes. What's the relationship from 4 minutes to 60 minutes? Times 15. So that's 15 problems. Or you could have done it this way. How do you turn 4 to 1? Divide by 4. So that is showing us the relationship of additive and multiplicative.